Find the cohesion, C, in pounds per square feet. In this problem, we are provided the major and minor principal stress values at failure for two triaxial tests. And we know that the soil is a clay in the consolidated drained condition. In problems like this one, the stress values are plotted and a semicircle is drawn. The cohesion is identified and the rupture line is traced. The rupture line passes through the cohesion point and is tangent to the semicircle. Also, the friction angle can be determined from the slope of the rupture line. However, we don't always know the cohesion and may need data from a second test. In this case, the rupture line is a line which is tangent to both semicircles, and the cohesion, C, is determined last. Also, for a multiple choice problem, it can be helpful to consider the possible solutions while solving the problem. We'll see how this works as we solve this problem. Back to our problem. For the first test, the confining stress is plotted and the axial stress is plotted, and the two are connected with a semicircle. For now, let's assume the cohesion is 0 and draw out our triangle using the points from the origin, the center of the semicircle, and the point of tangency. The friction angle is identified and can be computed using the arcsine of the radius of the semicircle divided by the distance to the center of the semicircle, represented by the letters x and r. However, these equations for the friction angle only apply when the cohesion is 0. Considering the latter equation, we note that this equation is a specific case of a larger, more general equation, shown here. If we shift our triangle such that the cohesion is greater than 0, we can calculate the friction angle as the difference between two other angles, alpha 1 and alpha 2. So we return to our given data. We plot the data from our first test, plot the data from our second test, sketch out the rupture line, and identify the cohesion, even though we don't know its value yet. Since the slope of a line is constant, we can solve this problem by defining and equating a friction angle 1 with a friction angle 2. Substituting in our general equation, we now have an equation entirely in terms of the radius of each semicircle, the distance to the center of each semicircle, and the cohesion. Keeping in mind that the units of x, r, and c are in pounds per square feet, the value of r1 is 800, the value of x1 is 1200, the value of r2 is 1150, and the value of x2 is 1750. The value of c, the cohesion, is found 4 times in the equation. Rather than trying to solve for the cohesion directly, it would be easier to remember that the left-hand side is equal to the right-hand side of the equation. And it may be easier to search for the value of c by guessing, such as 0, and solving friction angle 1 and friction angle 2. In this case, we note friction angle 1 is larger. This means our next value of cohesion we evaluate should be larger than 0. Now is where we turn to our possible solutions, and the question arises, what value should we next try for our cohesion? This is where test-taking strategy comes into play. 30 pounds per square feet should not be chosen as the next value for C, because if phi1, or friction angle 1, does not equal phi2, or friction angle 2, we know phi1 will be greater than phi2 as it was when we set c equal to 0, and the search direction will again be for a larger value of c. So by choosing c equal to 30, there's a 75% chance we will have to evaluate yet another value for the cohesion. Same is true for if we try c equals to 75 pounds per square feet. There will be a 75% chance we won't be done with the problem. But if we choose an intermediate value, such as c equals 45 pounds per square feet or 60 pounds per square feet, there will be a 50% chance that we won't have to evaluate another expression. So if we evaluate the friction angle for a cohesion of 60 pounds per square feet, Phi1 equals 38.89 degrees and Phi2 equals 39.09 degrees. Since Phi2 is larger, we know to use a smaller value for cohesion. Unfortunately, being particular about which of our 4 possible solutions to first evaluate did not pay off in this instance, but it is still a good habit to get into, especially if the equations are messy and time is of the essence. We'll next try a cohesion of 45 pounds per square feet. Phi1 equals 39.62 degrees and Phi2 equals 39.60 degrees. Since these two values are virtually the same, we know the cohesion is 45 pounds per square feet, and the answer is B.